Hi Gators! I hope you guys are doing amazing. In the chapter so far, we've been learning a lot about area and perimeter. We've solved many different kinds of problems in many different ways. But today I want us to take a step back and look at the relationship between area and perimeter. So what do they have in common? Are they always the same? If area goes up, will perimeter go up? If perimeter goes up, does that mean the area goes up? And the same if they go down? So these are the questions that we're going to look at today to get a little bit of a better grip and understanding on these concepts. So today we're looking at problems that have the same perimeter but different area, and that's a little bit of a spoiler to my next question. So are area and perimeter always equal? That is to say, if I know my area is 4, does that mean my perimeter is going to be 4? Well, let's look. I've drawn a rectangle here. It has a width of 2 and a length of 4 units. So we can solve for the area by multiplying 2 by 4 and getting 8 square units. If I count my way around my shape, or if I add my side lengths, I'm going to find the perimeter is the same as 2 plus 2 plus 4 plus 4, which will get me to 12 units. So are they always equal? No, they can be, but they seldom are. All right, Gators, if two shapes have the same perimeter, does that mean that they're going to have the same area? So I want you to take a minute and think about that before I show you my pictures. So that's the same as saying, if I walk around my park by my house, and I walk around the outside of my park and it takes me 8 minutes, and I call my friend Julie, and I say, Julie, how long does it take you to walk around your park? And Julie says, it takes me 8 minutes. And I'm like, wow, that's crazy. It took us both 8 minutes to walk around our parks. And then I call my friend Joshua, and I say, Joshua, how long does it take you to walk around your park? And he goes, it takes me about 8 minutes to walk around my park. And I'm like, oh my goodness, we must all have parks that are the same size because it takes each of us 8 minutes to walk around it, right? So let's look at that. Here's my park, here's Julie's park, and here's Joshua's park. You can see I've already counted around my perimeter. My park, it takes me 8 units to get around. It takes Julie 8 minutes to get around hers. And it takes Joshua 8 minutes to get around his. But if we look at the squares inside of our parks, or those unit squares that help show our area, we can see that the area of my park is 3 square units. The area of Julie's park is the same. It is 3 square units. It's just a different layout. But Joshua's park is 4 square units. So while they can be the same sometimes, it's not a guarantee, right? If your perimeter is the same, it doesn't mean that you have the same area. So today they're going to ask you to compare some shapes and solve some problems using this. I want us to go through it together one more time. So we're going to look at another rectangle. This rectangle here is 2 units by 3 units. This is a great place to go ahead and pause and get a scratch piece of paper if you want to work along with me. Please feel free always to pause this video wherever you need to work at your own pace, and feel free to go back and watch if something didn't make sense to you. All right, Gators? So I've already solved this. My area is 3 by 2, which would be 6 square units. My perimeter would be this side, 2 plus 2 plus 3 plus 3, which would give me 10 units. All right, so this is the rectangle that they gave us. And then they're going to ask us to draw a rectangle that has the same perimeter, but a different area. And I'm going to show you guys a cheat. All right, so a good strategy for trying to make a rectangle that has the same perimeter or even the same area is to go ahead, and if this is a rectangle that is larger than 1 unit on the side, we're going to make one that is 1 unit and just count our way around and make sure that it's the same number of units around as this rectangle here. So I went ahead and did that. You could see I drew 1 because, like I said, we're only going to make it 1 wide, and then I counted 2, 3, 4, 5, 6, 7, 8, 9, and 10. Because we're not going to count inside for perimeter, right? So I'll give you a second to go ahead and look at this. So just to double check that this does have a different area, I'm going to count my squares. So my squares are 1, 2, 3, 4. My area is 4 square units. My perimeter is still 10 units. So I've drawn something that has the same perimeter as the rectangle above, but it has a different area. So the area has gone from 6 square units to 4 square units. All right, and they asked me to draw a rectangle, but they could have asked me to draw any polygon that had a different perimeter, a different area. So those are some other examples of how you could have drawn it if they didn't ask you to draw a rectangle, but we were asked to draw a rectangle, so this is what we drew. All right, so finally they're gonna say, which of your rectangles had the greatest area? And I'm gonna ask you why. So let's look. The area for our top rectangle was 6 square units. The area of the rectangle that I made was 4 square units. Which one had the greater area? The one they gave us, right? Now, why do you think that is? It's kind of tricky. So if you look at this shape, you can see that they've stacked the rows higher in this rectangle than we did here, right? This side length is 2. There are 2 rows of unit squares. And this one, we only have 1 row, right? So when you have a shape that is very long and skinny, you have a lot of sides that are showing inside your square. You're showing almost every side of these squares. Like this square, we had to count 3 of these sides. For this square, we had to count 2. We didn't count these 2. For this one, we had to count 2. And for this one, we had to count 3. So because we have so many sides of these squares showing, it's gonna have a higher, it's easier, it's faster, takes less squares to get to the higher perimeter. But here, you have a lot of sides that are hidden in these rows that are stuck together. So here I only count 2, here I only count 1 of those sides. Here I count 2, 2, 1, and 2. So the sides that are being exposed are a lot less. So you're able to fit in more unit squares when you stack them because you're exposing less sides to count for the perimeter. Does that kind of make sense, Gators? All right, so we're gonna go ahead and look at some of the problems they're gonna have you solve today. The problems they're gonna have you solve are a little bit easier than the ones we just did together. The ones we just did together were more to explore what area and perimeter were and how they relate. So I'm gonna go ahead and show you some problems that you're gonna see on your worksheets today. So in your worksheets today, they're gonna show you 2 rectangles and they're gonna give them to you. You're not gonna have to draw them. And they're going to ask you to find the area and the perimeter of these 2 rectangles, and they're going to ask you to compare them. So they're gonna ask you to find which rectangle has the greatest area. All right, so here's a great place to pause so that you can do this problem along with me. Go ahead and draw out your rectangles and go ahead and try to solve if you feel really confident. All right, Gators? So I'm gonna go ahead and start. My side length here is 2 units, and this side is 2 units. So my area would be 2 times 2, which equals 4 square units, or 4 units squared. And then if I find my perimeter, I'm adding 2 plus 2 plus this 2 plus this 2. So I'm adding 2 plus 2 plus 2 plus 2, and I'm gonna get 2, 4, 6, 8 regular old units. All right, so my area was 4 square units, my perimeter was 8 units. Now let's go to rectangle B. Rectangle B has a side length of 1 unit, and it has a length of 3 units. So now I can solve. My area is gonna be 1 times 3, which is gonna be 3 square units. And my perimeter would be 1 plus 3 plus 1 plus 3, or 4 plus 4, which would equal 8. So as you can tell from the title of our lesson, we have the same perimeter once more. Both of these rectangles have 8 units, but this one, the area is 4 square units, and this one, the area is 3 square units. So again, you're seeing what I'm talking about. If you stack the squares to make a wider shape, you're gonna end up with a bigger area because you can fit more squares in with hidden sides that you're really not counting. But when you flatten that rectangle and make it only 1 unit wide, the area is gonna go down because more of the sides are showing, so you're gonna get to that 8 units a lot faster. All right, so which one was greater, rectangle A or rectangle B? Well, rectangle A was the greater rectangle. It had the greater area. So I would write in A. All right, I have one more for you today, and then you can go ahead and start your page. If you feel confident, you can go ahead and start that now. But I'm gonna show you our 2 rectangles. Go ahead and take a second, pause the video, and record the dimensions or those side lengths. All right, so I'm gonna start. I'm gonna count. Rectangle A has a side length or width of 2 units and a length of 1, 2, 3, 4, 5, 6 units. Rectangle B has a length of 4 units and a length of 1, 2, 3, 4 units. So this one is actually a square. Remember that all squares are rectangles, but not all rectangles are squares, right? So I'm ready to solve. My area is gonna be 2 times 6 for rectangle A. 2 times 6 is 12 square units. My perimeter is gonna be 2 plus 6 plus these 2 plus these 6. And I'm gonna end up with 8 plus 8, which would be 16 units. All right, so our perimeters are probably gonna be the same because that's the central idea about today's lesson, but let's double check. So our area is gonna be 4 units times 4 units, which is gonna be 16 square units. And our perimeter will be 4 plus 4 plus 4 plus 4, or 4 times 4, because we have 4 groups of 4. Either way, you're gonna find that your area is what? 16 units. So in this case, when you were given a square, we found out that the area and the perimeter were the same, except for the units, right? Area is square units. So now we can compare our rectangles. Which of these rectangles was bigger? Well, they both had the same perimeter, but the area of rectangle A was 12 square units, and the area of rectangle B was 16 square units. So again, because they stacked it higher, they were able to fit in more squares with less sides being shown. These rectangles in the middle, they don't have any of their sides being counted toward the perimeter. But every rectangle on this shape has at least one of their sides being counted toward that perimeter. So they couldn't fit in as many squares, right? So we would write in rectangle, in this case rectangle B, has the greatest area. All right, Gators, feel free to rewatch this video. If you have any questions, please go ahead, practice these problems, reach out to your teacher. We're always happy to help. We miss you, Gators. Have a wonderful day. Bye.